create a crystal in PowerPoint. So at first, let's open on the PowerPoint and black presentation. Select this and delete this by hitting the delete button. So to create a 3D crystal, actually a simple cubic system, we'll have to create the 3D cube at first without the atoms, just the lattice of the cube. To create the 3D cube, we'll take the rectangular shape and set the length and width of 8 centimeter by 8 centimeter. So we'll create a cube of 8 centimeter length, width and height. So it's just a rectangle now with the length and width of 8 centimeter by 8 centimeter. So to convert this into a 3D cube, we'll have to right click on it and go to the format shape, effects, 3D format and depth. By giving it a depth of 8 centimeter, it will be converted into a 3D cube of all the dimensions of 8 centimeter. We'll select the material as wireframe and contour as 10 points. Contour controls the thickness of the lines. So we can also change the colors. Select this. So it's basically a 3D cube now. 3D cube, we can check that. As you can see, it's a 3D cube. It's a 3D cube without the atoms. So we can make the atoms. To make the atoms, I'll select the circle shape and give it a length and width of 2 centimeter by 2 centimeter. I'll create an atom of 2 centimeter diameter. So now I can see it's a 2D circle of diameter 2 centimeter. To convert this into 3D atom, I will go to the 3D format, select the top bevel as the first one, and bottom bevel as the first one also, and width and height as same as the radius of the atom. In our case, it's 1 centimeter. I'll just add this 1 centimeter. 1 centimeter. One centimeter. Now you can change the color from the fill color. Let's select this color. It's pretty nice. So it's a 3D atom now. I can copy and paste it by selecting and holding the Ctrl plus D button. So it's a 3D cube now. So let's place these atoms at the atoms at the atoms at the four corners of the cube that we made. Make sure you align it perfectly, because that's what will control how beautiful your crystal will look like. Also, we have placed the four atoms at the four corners. Now by holding the shape button, we can individually select all these four atoms. We have selected all these four atoms. Now group it by right clicking on the atoms and grouping it. So we have grouped these four atoms. Again, selecting all these four atoms. Sorry, place it right on the place. Also, again selecting it and pressing the Ctrl plus D, we can copy and paste all these four atoms. So we know that a cube has 8 atoms, 4 atoms at the top and 4 atoms at the bottom. So in our case, these 4 atoms are the 4 atoms at the top and these four atoms are at the four atoms at the bottom. So how can we shift the distance? Or we can control the distance by a term, distance from the ground, which is at the 3D rotation, and distance from the ground. So we will have to understand this distance from the ground term, as it is the most important thing to create the crystal. So in our case, everything has a distance from the ground that we can see on the screen is 0. That means the atom, the circumference of the atom is touching the screens, which means the center of the atom is lying at the minus 1 centimeter depth from the skin, which means 1 centimeter, which means the circumference is touching the skin, and the circumference has 0 distance from the ground, but as it has a radius of 1 centimeter, so the center of the atom is lying at 1 centimeter distance inside the skin. So inside the skin is minus and the outside the skin is plus. So the center is lying at minus 1 centimeter distance from the ground. The ground is the screen. So to align the cube and the center of the atoms at perfectly, we'll have to give these four uh, upper atoms a distance from the ground of 1 centimeter. Giving it a distance from the ground of 1 centimeter will bring the center of the atom at as the same distance from the ground of the cube. So we're basically bringing these four upper atoms outside this inside out from the skin. So these are four atoms. These are four bottom atoms. To align in the center of these four bottom atoms and the cube, we'll have to give it a distance from the ground of minus 8 centimeter. Minus 7 centimeter, sorry. Minus 7 centimeter. Because the center is already lying at minus 1 centimeter distance from the ground, giving it a distance from the ground of minus 7 centimeter will keep the center as same as the bottom level of the cube that we made, which is minus 8 centimeter. So align this over these atoms and select everything and grouping them will give us a 3D cube. You can check it. As you can see, it's a 3D cube. It's a 3D cube. To remove these color lines, we'll go to film line, line, and no line. So the problem is resolved. So now we have a simple cubic system. To convert this simple cubic system into BCC, we'll take this atom. Sorry, we'll take this atom. We will take this atom and place it at the dead center of the cube. So we'll have to set this middle atom at the dead center of the cube, which will be at the minus 4 centimeter. So the center is at already minus 1 centimeter distance from the ground. So by giving it a minus 3 centimeter distance from the ground, we can set this at the minus 4 centimeter distance from the ground. So we have given it the desired distance from the ground, and we'll select and group it. Now we have a perfect BCC structure. As we can see, it's a BCC structure. It's a BCC structure. So accordingly, Following these steps, we can create any crystal, including simple cubic, body-centered cubic, and face-centered cubic. For face-centered cubic, we'll set atoms at these places, at these centers, at these bond centers, and select those individually, group those, and give those as distance from the ground of -3 centimeter, which will set them right at the middle of the site atoms, and thus we can create BCC, sorry, FCC, the face-centered cubic system. Try it yourself. Hope you understand this video. Thank you very much.